Hello! We're going to walk through an example of how to apply a linear regression in order to find some sort of connection, if there is one, or to see if there's no connection between two sets of data that we're going to compare. So really, linear regression is all about seeing if there is a connection between the changes between two sets of data. As one goes up, does the other one go up too? As one goes down, does that one go down as well? Or are they opposites? Does one go up, the other one goes down? Or are they just totally unrelated, which could also happen? So for an example here, I was thinking of baseball, as I often do, and I've got some stats here from last season. Let me get those right here. All I did, and to get these, by the way, all I did was I went to search engine, I went to Bing, I did MLB stats, and boom, pops up right there. That's it. All sorts of stuff I can get right from this website. So I go back here to my question. Really, my question I want to answer is, does the amount of runs a team scores correlate to the number of wins? Or in other words, is there a connection between the runs a team scores and the wins they achieve for that season? So I used 2012 data, which as a Cubs fan kind of saddens me. They didn't do so well. I've got data for the National League right here. So 16 teams. And all I'm really concerned with, the names aren't really that important. There's two pieces of data that go with each team. The number of runs that they've earned, which is in this column here on the left. I'm going to treat this as my X. X is the independent variable. This is the one that really should be making the Y change, if you want to think of it that way. Or it might not if there's no connection. But traditionally, X is independent, Y is dependent. And my number of wins I'm going to set for my Y. So each team just becomes a data point. So the Rockies here have they've got 758 runs. They had 64 wins. So really their data point is just going to be 758, 64. That's it. Each team becomes this. We don't need to use this though. This is just so you can see what it looks like on the graph. Using Excel, I think, is the easiest way to make a graph and to present your data table. You will need to present your data table for the project. And just saving it in here, you can just print this out, turn that in, and we can make the graph through Excel really easily. I'm using Excel 2010 for PC. There are different versions out there. If your version is a little bit different, my advice is to go to YouTube and do a search for linear regression, spelled just as it is here, and Excel, whatever version you might have, be it for Mac or be it 2007, 2013, whatever it is. With this, we want to make a chart. That's going to be our graph. And so we want a scatter plot. Scatter happens to be right up here. So I selected all my data. I just put a box around it here. I go to scatter. And I'm going to choose this one right here, scatter with just the markers right there, and boom, there it is. I'm going to enlarge that a little bit. So we see our points are on here. Our X goes up to, a little past, right around 800 here. Starts at 600. The Y goes from around 55 games. There's the Astros. Sorry, guys. Cubs aren't doing too much better, unfortunately. All the way up to close to 100 wins here. I think that's the Reds. But we don't have a line of regression here, a line of best fit. We don't have a whole lot, but we can get that. If you go to chart layouts, up here you see on this one, on my particular layout here, it's the third one down, in the third one to the right. It's got a little f of x up there, which stands for formula. So I'm going to click this one, and boom, oh, look at that. Look at that right there. Look at that. Oh, right there. I'm going to move this guy a little bit out of the way so we get a better view of this. Boom! Right there, y equals 0.1102x plus 4.7313. That is the equation for our line of best fit. Excel automatically computed it. I love technology. Makes our lives easier. And even, it gave us the r squared. Man, oh man, no more punching in the calculator. Just throw it right into Excel here. Take advantage of the power that your computer gives you. Awesome. And we can interpret this a little bit. So this 0.1102x, remember x is rise over run. So 0.1102 we can make into a really messy fraction. Let's see, let's make that into a messy fraction, why not? We can look at that as .1102 over 1. Okay? That's not the world's nicest fraction, but it works. And really, when we look at that, that's our slope, right? Anything can be put over 1 and make that a fraction. It doesn't change its value or anything. But this is really just the same thing as we can put on up top there. That's delta y. That's the change in y over the change in x. So let me blow that up a little bit there too. Kind of working in a small font. Okay, see that clear? Every time y goes up by 0.1102, they're both we got positive here. So when this one goes up by 0.1102, then this one goes 1. So in this case, our y, we said, was wins. So that every time we have a change in wins, we get a change in runs. Runs is our x. So every time I get one run, that should connect to 0.1102 wins. So almost a tenth of a win. Okay, that's what the model says. That would fit. But look at the scatter plot here. The scatter plot is kind of all over the place. We see, yeah, we've got these guys that kind of connect close to the line. But look at the Astros. I mean, yeah, they're kind of weird, but they're all over the place down here. Look at these guys up top too. The teams that were really getting the most wins. I mean, yeah, they got some runs, but other teams got more runs than them, and they didn't fare nearly as well with wins. And by the way, while we're here, let's go ahead and change to make it nice when we print it out here. We said our x was our runs, and we said that the y is the wins. And we'll just call this, usually do y versus x, so wins versus runs. And this guy over here, I don't even think we need this. We can just totally delete that. Go! Undo that. We don't need this guy. We need everything else, but this guy right here, there we go. We get more space now. Okay, and our r squared, I'll move this, make it so it's very clear, easy to read. Our r squared, though, this value, wow, wow. Let me boost the font on this. There we go, that's perfect, okay. R squared is 0.2553. Remember, the closer r squared is to 1, the more accurate your model is going to be. This is not very accurate. And we can see that from the graph, because we've got all these wild points up here, we've got these wild points down here. So, based on this, I would say there is little connection let's little, if any, connection between wins and runs. Our R squared, we've got a model here that is supposed to fit, but our R squared is just so low that it kind of points out that the model is just really not worthy. Okay, so Excel is what I would recommend, and we do have this at school. And you saw how easy I was able to do this. I just had to get my data. Actually, getting the data and typing it all in here was probably took more time than doing this. The other option we've got is our old friend WolframAlpha, and we can put in each point by doing linear fit, and then your first don't just plug this in. That will not help you. Those are just random numbers. You can start inputting your data. Put your x, comma, space, your y. We got these kind of curly brackets here, comma, no space, just go straight to the next curly bracket. 765, this is my next x, space, 88, da-da-da-da-da-da. I already ran all this, I got this. Unfortunately with WolframAlpha it cuts you off. I think I got about 11 data points here, and then beyond that it just stopped working. So we get something similar. Oof. Our R squared is even worse with these first 11 points. That's really bad. We're all over the place. We are all over the place. This is not a good model. So this is kind of like the option of last resort. You can hit print screen if you're here, if you do use WolframAlpha. So I can do that right now. I'm going to find on my laptop where I have print screen these days. I don't use this guy too often anymore. And if you hit Control V, or if you just go to paste, paste not showing up. I'm a keyboard shortcut guy. It's faster for me. And if you learn it, it's faster for you too. I'm going to Control V. There's that screen that I was just at a second ago. I double click this. I get my menu to crop. I'm going to crop everything, but I just want this graph. I can copy down the other data, the R squared and the equation and all that. Click crop again, and then I can stretch this guy out so we can actually see it. So this is not the best way to go, though. Please use this as a last resort. Excel is really the way to go with this. And that's what we use, in our careers and all that. It's a much more powerful tool, and you're going to be using this quite likely once you start working pretty much any job these days. They will find a way for you to use Excel. So that's about it. I'll put this file, make it available on the website so you can take a gander at it. And yeah, good luck. Have fun. Investigate something. Learn something new. And by the way, one last thing, this low R squared does not mean that this was worthless. It just means that now we know that you can have a winning team even if you don't score a whole lot of runs. And you can speculate why for that. It could be pitching, could be a whole lot of different stuff